Once again, welcome to this lecture on enzyme. We are now on part 4. So at this point, we will see what are the factors that affect enzyme activity. The first is temperature. All right? So how does temperature affect the enzyme activity? Higher temperature results in higher kinetic energy, which causes an increase in number of reactant collision. Therefore, there is higher activity. So for example, as you increase the temperature, the, the molecules move faster because of energy that is transferred to them. So as the molecules move because of the higher kinetic energy, there will be higher probability of collision between the substrate and the enzyme. So when they move, okay, the enzyme matches or the enzyme binds to the substrate because of collision. However, at low temperature, let's say at a freezing temperature, what happens is there are two cases. There's denaturation. Okay, denaturation. Remember, denaturation is unfolding of the native structure. And the other thing is when the temperature is low, there's a less kinetic energy. So less movement, okay, less movement of molecule. Therefore, the collision is not favorable and there is less chance of meeting between the substrate and the enzyme. For every enzyme, there is what we call optimum temperature. The optimum temperature is where the enzyme reaction is its maximum. In our body, the enzymes in our body act at optimum at body temperature, okay, 37 or close to 37 degrees Celsius. So as you can see in this graph, as the temperature increases, the reaction rate of the enzyme increases also until it reaches its optimum temperature where the reaction rate is at maximum. If you continue to increase the temperature, what happens is the enzyme will get denatured also. Okay? That's why denaturation will lose the activity or the reactivity of the enzyme. Okay? The second factor that affects enzyme activity is pH. Changes in pH affects enzyme activity by denaturation. So denaturation or unfolding of protein is brought about by the disruption of the salt bridge in the tertiary structure. Remember that tertiary structure of protein is governed by 4 forces such as hydrogen bonding, disulfide bond, hydrophobic effect, and salt bridge or electrostatic or electronic attraction between negatively charged and positively charged side chain of amino acid. So when acid or base are added to the protein, the salt bridge or the electrostatic interaction between the positively charged and negatively charged side chains are disrupted. Most enzymes have optimal activity in the pH range of 7 to 7.5. that is in the normal neutral, okay, neutral pH range. However, there are many enzymes that do not act, or they have activities beyond or below this range, such as our digestive enzymes that that are that have an activity at pH 2 or even higher than pH 7. Okay, pepsin has an optimum pH of 2.0. Pepsin cleaves protein or hydrolyzes protein in the stomach. And trypsin, it's also a hydro or proteolytic enzyme that works in the small intestine. So as the graph shows, as the pH increases to its optimum pH, the reaction rate increases also until the enzyme reaches its until it reaches the maximum or the optimum pH value. Then when the enzyme has reached its optimum pH, you would notice that the reaction rate goes down, okay? Because it begins, or the enzyme begins to denature. So the incorporation of base here, because the pH increases, so the incorporation of excess base could now interfere in the salt bridge, okay? Salt bridge in the tertiary structure of protein. So we can say that the protein is now being denatured. The third factor that affects enzyme activity is the substrate concentration. So the analogy here is, if you have a container that has 10 substrates, okay, and also 10 enzymes. At a constant enzyme concentration, the enzyme's activity increases with substrate concentration. So for example, you have 10 enzymes, okay, 10 particles of enzymes in the container. As the concentration of substrate increases, the activity also increases. You add one substrate, activity increases. You add two, okay, three substrate, 4, 5, and 6 substrate, the reaction rate increases also, as shown in this graph. So as you keep on adding substrate, the reaction rate increases. However, there will come a time that the reaction rate reaches its maximum, okay? It will create a plateau. What does that mean? When the enzyme reaches a saturation point, say for example, there are 10 enzymes here, and you have added, say, 10 enzymes or more. The 10 or you have added 10 substrate rather. The 10 enzymes, the 10 particles of enzymes can no longer act on the excess substrate, because all enzymes
have already been saturated. Okay? So, no matter what you do, as long as the enzymes are saturated, then there will be no increase in the reaction rate. Okay? So, substrate saturation happens when the concentration or when the enzyme reaches its saturation point. Okay? And the active sites are all full. The measure of um, enzyme activity can also be determined by turnover number, in which the number of substrate molecule converted to product per second per enzyme molecule under condition of optimum temperature and pH. Here in this graph, it illustrates the effect of enzyme concentration. Earlier in the previous graph, we have seen that when enzymes are saturated, okay, if you add more substrate, then there will be no reaction, there will be no um, conversion into products that will happen because the enzymes are already saturated. However, here, um, at um, at constant substrate concentration, the reaction rate increases infinitely, okay, because the concentration of enzyme increases. So this is a function of reaction rate versus enzyme concentration. So as the enzyme concentration increases, the reaction rate also increases, as shown by this straight line. Why? The greater the enzyme concentration, the greater the reaction rate. So there will be more active sites that will accommodate the substrate. Okay?